In this video, you will learn how to derive some functions using the product rule. I have already discussed in the previous videos the rules in finding the derivatives, but let's recall what a product rule is. The product rule states that if y is equal to u times v, then dy over dx is just equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. Now let's solve some problems here. Let's say we're given this function x squared times x plus 1 cubed. How do we apply the product rule here? So the first thing we do is we identify two functions and then we find their derivatives. Alright, so we let u be equal to x squared and v is just equal to x plus 1 cubed. And recall that the product rule, dy equals dx, is just u times the derivative of v with respect to x plus v times the derivative of u with respect to x. Now let's apply that to the given function here. Let's first find the derivative of u. So u here is x squared, then du over dx is just equal to the derivative of x squared with respect to x. And derivative of x squared, we can use the power rule. So this is just equal to 2x times x to the 2 minus 1, which is just simply equal to 2x. And the next thing we do is we find the derivative of v. So v here is equal to x plus 1 cubed. We cannot just directly use the power rule here, so we use the chain rule in finding the derivative of v. So that would be derivative of v with respect to x is just equal to the derivative of x plus 1 cubed with respect to x. So using the chain rule, we can just say derivative of v with respect to x. This is just equal to the derivative of v. We let w as x plus 1, so derivative of v with respect to w times derivative of w with respect to x. So we let w as equal to x plus 1. Then our function v is just equal to v or equal to u cubed. And the derivative of w with respect to x is just equal to the derivative of x plus 1 with respect to x. And this is just derivative of x, which is 1, plus derivative of 1, which is a constant, is 0. Therefore, dw over dx is just equal to 1. So we already have dw over dx, and now we need to solve for this one, dv over w. So no more space, so I can just delete this. All right. So I'll just put that here. So we won't forget du over dx is 2x. Then we have dw over dx is equal to 1. Then we can delete this. Then we solve for dv over dw. This should be w. Sorry about that. W cubed, because we let w as x equals 1. So this is w cubed. Then dv over dw is just equal to the derivative of w cubed with respect to w. Then derivative of w cubed is just equal to 3 times w to the power of 3 minus 1. And this is just equal to 3 times w squared. Now that we already have both dv over w and w over dx, then we can find dv over dx. So let's delete this. So now we can solve for dv over dx. And that is equal to dv over w, which is 3w squared, times dw over dx, which is equal to 1. So this is just simply equal to 3w squared. Now we already have dv over dx and du over dx. So now we can solve for dy over dx. And by the way, we need to plug in back the value of w, which is x plus 1. So this is just dv over dx is equal to 3 times x plus 1 squared. Right. Now let's solve dy over dx. So we just plug in everything. Or just right here. Okay. So dy over dx is just equal to u, that is x squared, times dv over dx, which is 3 times x plus 1 squared, plus v is x plus 1 cubed. X plus 1 cubed times du over dx, which is 2x. Then we simplify this and we factor out common terms. So dy over dx is just equal to 3x squared times x plus 1 squared plus 2x times x plus 1 cubed. Right. And then we factor out common factors. The common factors here are x plus 1 squared and x. This one. Alright, so dy over dx is just equal to, we factor out x and x plus 1 squared. Then we'll be left with 3x plus 2 times x plus 1. Right? Then we simplify. Right. So this is just x times x plus 1 squared times 3x plus 2 times x plus 1 is just 2x plus 2. And then we combine like terms. So this is just x times x plus 1 squared times 3x plus 2x is 5x plus 2. So the derivative of the given function x squared times x plus 1 cubed, right, is just this one. This is our final answer. X times x plus 1 squared times 5x plus 2. Now let's solve another problem. Now let's say we're given this function x times square root of 11 minus x. Now to solve this using the product rule, we need to identify u and v here and then find the derivatives. So we let u be equal to x and v be equal to the square root of 11 minus x. Or we can just simply write v as 11 minus x to the 1/2. Again, let's recall the product rule. That would be derivative of y, the function, with respect to x is just equal to u times derivative of v with respect to x plus v times derivative of u with respect to x. Now let's solve for du over dx first, then dv over dx. So du over dx here is just the derivative of x, and that is equal to 1. And now to find the derivative of v, since v is equal to 11 minus x to the 1/2, we can use the chain rule here. So again, let's we let w be equal to 11 minus x. So v here would just be equal to w to the 1/2. And then the derivative of v over dw is just equal to the derivative of w to the 1/2 with respect to w. And this is just equal to 1/2 times w to the 1/2 minus 1. And that is equal to 1/2 times w to the negative 1/2, or 1 over 2 square root of w, because w to the negative 1/2 can be written as 1 over w to the 1/2. So this is our dv over dw. So let's write the chain rule. That is dv over dx is just equal to dv over w times dw over dx. Right, so let's find dw over dx. So w here is equal to 11 minus x. So dw over dx is just equal to the derivative of 11 minus x with respect to x. And this is just equal to derivative of 11, that is a constant, so that is 0, minus derivative of x is 1. So this is equal to negative 1. Now we already have dv over dw and dw over dx. So we can now solve for dv over dx. We just plug in here. So this is dv over w times dw over dx. So this would become 1 over 2 square root of w times negative 1. So dv over dx is just equal to the negative of 1 over 2 square root of w. And then we plug in back the value of w because we let w as 11 minus x. Therefore, dv over dx is just equal to negative 1 over 2 the square root of 11 minus x. So this is our dv over dx. Now we already have du over dx and dv over dx. So now we can solve for dy over dx. We just plug in everything. Okay, let me delete this. So dy over dx is just equal to u, which is x, times dv over dx, which is this one. So that is negative 1 over 2 square root of 11 minus x, plus v, which is this one, square root of 11 minus x, times du over dx is 1. So this is just equal to x times negative 1 over 2 square root of 11 minus x is just negative x over 2 square root of 11 minus x plus square root of 11 minus x. Then we add them up. We get the LCD. LCD here is 2 square root of 11 minus x. So this is just negative x plus 2 square root of 11 minus x divided by 1 times 11 minus x. So that is 2 times 11 minus x. Then we further simplify this. This would become negative x plus 2 times 11 minus x. This is 22 minus 2x over 2 square root of 11 minus x. Then we can further simplify this. So dy over dx is just equal to negative 3x plus 22 over 2 square root of 11 minus x. So this is our final answer.